chapter review problem number 8 together. So the first thing you want to do when you're so this is called the graphical method for basically for finding a resultant vector, and it is literally drawing it to scale very carefully and actually measuring your answer on paper. It's painstaking, it's detailed, and if you screw up your scale or you're sloppy with your angle, you will get the wrong answer. So the problem states, a dog searching for a bone walks 3.5 meters south, then 8.2 meters at an angle of 30 degrees north of east, and finally 15.0 meters west. Use graphical techniques to find the dog's resultant displacement. So we want to start by figuring out an appropriate scale. 3.5 meters west. You're obviously not going to draw 3.5 meters on your paper. Very often you can just swap centimeters for meters. 1 centimeter equals a meter. So in this case you could easily say, okay, 3.5 centimeters due south. Thanks. And I'm going to use 35 centimeters up here to make it visible. So we pick our start point and our end point and draw our first vector. So this is 3.50 meters south. And label it. That really helps. This is also where, and for you visual learners, you'll love this. This is where I really recommend the use of colored pencils, colored whatever you got, to keep track of your vectors. It's not nearly as important when we're doing the graphical, but when we're doing when we're doing algebraic vectors, you will absolutely positively need different colors to keep track of things. I just got new colored pencils, so they're brand new. They're all sharp. They're new colors. It's very exciting. You can use, every day when you walk in, if you want to grab colored pencils, do it. Okay, so our little dog walks 3.5 meters to the south, then heads off for 8.2 meters at an angle of 30 degrees north of east. Maybe I shouldn't have picked this one first. So when we say 30 degrees north of east, I want you to imagine a compass rose. I'm going to do a little side note here. Okay. Compass rose. You're all good with north, south, east, and west, right? You can all label a compass rose. You're clever folks. In vectors, directional vectors for displacement and velocity, we typically use that compass rose and we adapt it. So we will talk about north of east, east of south, south of west. So north of east starts at which one of those directions? Starts at east, goes north. So if we're looking at 30 degrees north of east, we're starting here and we're coming up so that that angle is 30. Okay? This always confuses people. This is always a tough one, and actually I have a practice sheet somewhere that I will dig out for you guys that I made on that concept, and that will be part of your 5th quiz tomorrow, is directional vectors. You'll have a quiz tomorrow. Formative instructional practice, you get a point no matter how you do. One of those. Okay, so we're going to go 30 degrees north of east. Now if I wasn't doing this graphically, I'd just sort of approximate a line. But we're doing this graphically, so I'm going to set my compass there, right on the end of that vector, and I'm going to come up 30 degrees from the east. And I'm going to make a mark right there. So that's my 30 north of east. Now I have to go 8.2 meters, so I'm using 82. Oh, this is going to be awful. Well, you know what? And this is a good object lesson on picking your scale. Looking at the whole problem before you pick your scale. Had I looked at the whole problem, I would have changed my scale. So, good. I screwed up. You get to learn from my mistake. So, for me, 88.2 is going to be out here and off the screen, and it's going to go right through my compass rose. And that's okay. Oops, right there. All right, now I'm just hoping that our dog goes, oh thank goodness, 15 meters west. Uh-oh. I have a little bit of a problem. So we're going straight west, and I'm going to go 1 point. Let's see. Now here's the other thing. When you're doing this graphically, and if you're using lined paper, that makes it easy. If you line up your compass rose with the lines on your notebook paper, you want to make sure you're actually on a level. So I'm actually going to draw a 90 from here, which, you know, a straight out mark so that I have something to guide on. And I'm going to go 150, which is my 15, this way. And then we'll redo this with a more appropriate scale in a moment here. Okay, so this one was 8.2 meters at 30 degrees north of east, and this was 15.0 meters due west. All right, so, whoo, that was crazy. That's okay. That's okay. We'll fix it up. We'll fix my mistakes. So what we want to find, now we've drawn the situation, and what we want to find is our resultant vector, which is just the magnitude and direction of the vector that connects the start and finish point. So now we're going to take our start point, our finish point, and draw our resultant vector. So first of all, we're going to measure the magnitude of the resultant, and you're going to do that just using the scale that you've established. So mine is hard to read from this angle. So let's see, that would be 80. So 7.9 meters. Now I have to find my direction. How am I going to do that?
You find the angle it is from west, southwest.
I'm gonna use my protractor. Yeah. And I'm gonna draw a little compass rose right there. And I'm gonna bring that up to meet my line. And I'm going to say that that's about 5 degrees. So it's about, that angle is about 5 degrees. So that's 5 degrees what of what? North of west. Good. That's fine. That's fine. That's the kind of mistake that you'll make a couple times before you get used to them. So that's 5 degrees north of west, because we started at the west and went north. So this is 7.9 meters at 5 degrees